Hello everyone. So we will be solving the third problem of the contest, which is the hot potatoes at Fairy Warehouse. So the problem states that there are 2n leprechauns sitting in a circles numbered from 1 to 2n. They are divided into two teams. Leprechauns with odd number belongs to red team, while those with even number belongs to blue team. Initially, some leprechauns hold a potato. Uh, the game lasts for k rounds. At the beginning of each round, both team knows the current position of all potatoes. Then simultaneously, each leprechaun holding potato does exactly one of the following things. They can either keep the potato or they can pass the potato to the next leprechaun clockwise, provided the next leprechaun does not hold the potato at the beginning of the round. If the next leprechaun hold a potato at the beginning of round, the current holder must keep the potato. Whether a potato can be passed depends on the position of the potato at the beginning of the round. Under these rules, every leprechaun hold at most one potato at a time. When all key rounds are over, the final bell rings. You need to tell the score of each team is defined as the number of eliminated leprechauns of on other team. All members of each team cooperate and share available information to maximize their team score. You need to find the maximum score that they can achieve, right? So let's take a test case. Let's take this test case, right? 2 1 and 0 0 1 1, right? So give me a second. So the test case here was this one, that we had 0 0 1 1, right? And they are sitting in a circle, right? So how would they look like? 0 0 1 and 1, right? Great. Now let's try to see what would happen, right? First, let's see which team they do belong to. This belongs to red team, this belongs to the blue team, this belongs to the red team, and this belongs to the blue team, right? Now whenever you uh, tackle the type of problem which contains a game, right, you need to think of how or what is the optimality in solving these kinds of problems, right? So what I'm trying to convey to you is you don't need to think of K games, right, or K moves, right, or uh, rather K games would be a better thing. Like if the game goes on the K times, right, means they can pass K moves, then you don't need to think of all the K moves. Instead, think if the game was only of one move, right, what would happen, right? Because see, this player, right, let's call him a player A, does not have any idea of when the game would be over, right? Or even if he knew, if he had an idea that the game would last for K moves, let's say player A had an idea that okay, let's not take A, let's take this player, right? Let's name it him as Alpha, right? Okay, so if Alpha knew that okay, if the game lasted, let's say, two moves, right? So the best would be to pass this one to someone else, right? But think of it, if Alpha passed the one to someone, to the one next to him, right? And let's say if he holded that until the very last second and then threw the ball at the last second, then the move of Alpha, even after calculating that the game would last for k seconds, that would be useless. Am I making sense to you? What I'm trying to say is, let's say Alpha had an idea that okay, game would last k moves, right? The next person, he threw the ball at the very first second, thinking that okay, he will also throw the ball and it will keep moving and ultimately reach to an place where we will gain a point, right? Let's say he thought with this approach, right? But the player who was sitting next to him, let's call him as Beta, right? When Beta got the ball now, he said okay, okay boy, let me hold the ball for last second, and at the very last second what I will do is I will pass the ball, right? So as soon as Beta passes the ball to, let's say, Gamma, right? Sorry for these names, right? So Beta's team will get the point, right? So even if Alpha calculated every move and thought that passing the ball would be a good option at the first second, it wasn't good. Why? Because beta was very smart enough to keep the ball till the very last second and throw at the last second, right? So the problems, you see, the problem is not about k moves or k seconds. The problem is that if it was the last second, what would be the move, right? The problem boils down to only this part. Now I hope the solution which we will look will be more clear, right? Let's look at this test case first and try to understand what's the solution for this, right? This was red, this was blue, this was red, this was blue. So this, let's say even if k was equal to 2, right? Sorry for that. Yeah. So even if k was equal to 2, right? What will blue do? Blue will wait till the very last second. Why till the very last second? I have proved that to you, right? So blue will keep waiting, right? And blue will throw the ball, throw this one as soon as it was the last second. Means when k equal to 1, the last move was there, he will throw the ball, right? And as soon as he threw the ball, it will become 1, right? This becomes still is 0. This red can't throw the ball to blue because at the start of the second it was already a 1, so you can't throw the ball at that very moment, right? So this still remains 1 and this becomes 0. So this is the final position of the game, right? This is red, this is also red, this is blue, and this is blue, right? So blue have no ones and red have two ones, right? So in this case what we will say, blue gains 2 points and red gains 0 point, right? Why? Because if you had a 1, that means you lose, right? So that is the reason everyone is holding that 1 till the very last second, and as soon as they had an opportunity to throw the ball, they will throw the ball, right? Now you might think of a case where, hey, but what if uh, uh, you can think of a case like this is. So from this what we can derive is, we just need to wait for last second, right? Now you don't need to wait for in fact last second. What you can say, you can say, okay, wait a second, really sorry. Yeah. So what you can say is, if I am at, let's take a test case just to be more clear, right? Let's take a bigger one. Let's say we had this one, right? It's a big test case, right? We will try to understand it so that you will have more clarity on it, right? Okay, so let's create a circle around it, right? Yes. So 1 0 0, uh, rather than creating a circle, I guess writing it straight away and then thinking the first and last are connected together will be a better idea, right? So let's do that, right? So let's say 1 0 0 1 1 1 1 0 1 0 1 0 1 1, right? This will be, let me change the color so that it will give you a better clarity. So this is red, this is blue, right? This is red, this is blue, this is red, this is blue, red, blue, red, blue, red, blue, red, blue, right? Great. So even if the game lasted for 4 moves, we are not interested in that thing, right? We are interested in the thing that, okay, this is the last second, right? This is the last second, and now I need to make a move, right? This had a 1, right? What he will do? So what is a smart move? At the very last second, throw the bomb in someone else's hand. So this becomes a 1, this becomes a 0, right? Now this had a 1. Can he throw it to the next person? No, he can't. He can't. Even he can't. Can he throw the ball? Yes, he can. So let me copy these numbers directly. This one will be thrown to this one. So this becomes a 0. This becomes a 1. Right? This one can be thrown. Yeah, it can again be thrown. Oh, damn. This becomes a 0. This becomes a 1. Can this ball be thrown? Yes, again it can be thrown. So this becomes 0. This becomes 1. This becomes a 1. And this one will check for the previous, this one, right? Initially this had a 1 already. So you can't throw the ball at the first or the 0th index because its initial value was 1, even though it was converted to 0, but its initial value was 1, right? So you won't be able to throw it. So this is the final string that you will have, right? Even the game lasted any number of seconds, you need to just calculate for 1 second, and I have proven it why, right? Great. So let's see which team scored how many points. Red had uh, red will see for how many blues has won, right? So red points will be these, right? So one blue, two, three, four, five, six, and seven. So red will get 7 points, whereas blue will get all the reds which has 1 point. So this is the one, and uh, this is the one, right? So blue will get 2 points, right? So this is the final ultimate score that we should obtain, and you can see, yes, that is the final score, right? So the problem solution was this only, right? So if you still have doubt in the proof, right? So why are we not interested in K moves, right? Why will someone hold till the very last move? It is very obvious. And the obvious part is, if let's say a player, right, has a 1, and he throws the ball at the very first second to B, right? B will hold the ball till the very last second because B is smart, right? If B is smart, he will hold the ball till the very last second, and what he will do? He will throw at the last second to the neighbor, right? So the neighbor team will be in A, right? So he will throw the ball at the very last second, and he will get the point, right? So he will get a +1 for that because he will throw at the last second. So every player needs to be very smart of what time they should throw the ball. So at what time should they throw the ball? At the very last second itself, right? So that is a very obvious and good move, right? So this was the whole solution. Let's look at the code, right? So what I'm doing, I'm saying if s of 2n minus 1 means the last element is equal to 1, and if s of 0 is equal to 0, then I will say flag equal to 1. What is the advantage of that? I will tell you that as well. What I'm doing is I'm traversing from 0 to 2n minus 1, right? I'm checking if s of I equal to 1. What I will do, I will do s of I equal to 0, and s of 0 equal to s of I equal to 0, and s of I plus 1 equal to 1, right? What does this mean? If let's say I'm standing at let's take a number, right, so that we can have a clarity. So if we are at this index, right, what we will do, we'll simply check if the adjacent element is 0 or not. If the adjacent element is 0, what we can say, I will say, hey, make this 1, right? This becomes a 0, this becomes a 1, and now you won't be you won't be going on this index again. Why? Because this one has been passed to this 0 at the current move, right, at the very last move. So this index won't have the move for future. Are you getting it? No. Let me again explain you if it was not clear. Let's say this was, let's take 0 0 0 1 0, right? And let's take again a 0, right? Now what will happen is, this one at the very last second means this is the end, right? This one will be thrown to this one, right? So this becomes a 0, this becomes a 1, this still remains a 0. Now you will think, hey, why not this will throw at this one 0? It can't throw because it was already k equal to 1. That was the very last second, right? That was the last move that could have been made. And 1 at the start of the game, he throws the 1 to the neighbor, and the neighbor had no move because the time's over, right? So that is what we are doing. If s of I plus 1 is 0, so what we will do, you will simply do I plus plus, because you don't need to traverse on the, or you don't care about the next index, right? Because you have already placed a 1 at that place, right? And he will not have a chance now. Great. And if it already had a 1, then you don't have a chance, right? Means, let's say if this was a 1, this was also 1, at the very last second this one can't be thrown because that violates the rule of having more than one potato in a hand, right? It already had a 1, you can't throw 1 at it again, right? So I hope these things make sense to you, right? Now if flag is equal to 1, I will convert s of 0 to 1 and s of 2n minus 1 to 0, right? Now let's look at what the flag actually was, right? So what I was trying to say is, if s of 2n minus 1 is equal to 1, right? What does this mean? If the last element is 1, right? Let's say this was 0 and this was 1, right? So what will happen, this one will be transferred to this one because they are in a circle, right? So this becomes a 1 and everything else, and this becomes a 0, right? But think of this, if you did this at the start of the game, then you will start with a 1, right? That will make a problem to you, right? That will create a hassle for you. Why? Because this one again needs to be checked. This one will throw the 1 to the next index, right? So you don't want that because that is the very last move when this one will throw this 1 to 0, right? So that is the reason we are handling it separately. I hope I am making sense to you. If not, I am quickly repeating it once again. See, because it is the very last move, right? You just need to make sure that this one goes to this 0, right? You can do this at the you need to do this at the start of the game. Why are we doing this at the start of the game? Because see, if one is there, right, it might be a case that this one, let me give you a brief explanation why I did this thing, because is a very interesting edge case, right? Let's say this one, it was not initially there, this was a 0 and this was a 1, right? This is the last index, right? This is the very last index, 2n minus 1. So if it was a 0 and 1 was there, what will this one do? This one will throw this 1 to this index, right? And now this will become 1, and and the game gets over, right? And after that, if you check that, hey, is this 1, can this 1 be transferred to this 0? It will say yes, right? But answer should be no, right? You can't transfer. Why? Because that was the very last move, right? So that is the reason why we are doing it at the very start, right? At the very start we are doing it, that hey, if this is a 1 and this is a 0, right, you can throw this 1 to 0, right? Now what would happen, this should have become a 1, right? This is the first case. Now you might think why we are doing at the start of the game, not at the end of the game, is very clear. This one proves, right? Now you might also think that, okay, why are we not updating it at the very start, right, itself? The reason for do not doing it is because if this becomes a 1, then you need to then there will be a problem, because this one can be transferred again, and as it was the very last move, you won't be able to transfer it. You need to make sure that you don't transfer it again, right? So that is the whole reason. If you have any doubts, you can ask in the comments. I would love to help this part or any part of it, right? So that is it. That's a code, right? We had a red and blue point. If s of I is equal to 1, and if I modulo 2 is equal to 0, then blue gets a point, else red gets a point, right? And you need to print red and blue, right? So that's it for the video. If you understood the problem statement, you can give a like, you can do subscribe as well. uh, Quickly, a time complexity of the problem, it is big of n, because we are running a single for loop every time, and we are not interested in k at any given time, right? So k is almost already neglected, right? Even if it's odd or even or anything, right? So that's it. I hope it was useful for you. If yes, please do give a like and subscribe as well. Thanks for watching.